just do a quick welcome to everybody to the Learning from Leaders session hosted by the Yale Center for Customer Insights. We started this session this year to bring practitioners and academics together and sharing their knowledge. And we have a great speaker for you today, Renee Richardson Gosline. She's a senior lecturer in the Management Science Group at MIT Sloan School of Management and the lead research scientist in the Human AI Interaction Group at MIT's Initiative on the Digital Economy. Renee is an expert on the intersection of behavioral science and implications for AI and cognitive bias and human decision making. So I think we have a really great talk for you today, really applicable for practitioners, and we're excited to get started. I will just do a couple of housekeeping things. If you have questions, please pop them into the Q&A function, not the chat. And then if you have any questions for me specifically about the series or anything like that, you can chat me directly. All right, Renee, I'll pop it over to you.
Thanks so much, Emily. And thank you everyone for being here from your various corners of the world. I'm honored that you are spending some time with me. So let me share my screen and hopefully you can see this. If there are any questions, as Emily said, feel free to pop them in the chat. I'm happy to be as interactive as need be, but I have some stuff I would like to get through if time allows. And this really is around focusing on the human element of human AI. And I think that's important because a lot of sort of the questions and the discussion around how to improve predictability or how to minimize bias really revolves around the features or the properties of the algorithm or the machine learning or other properties with regard to what kind of decision is being made, for example. But as a behavioral person, I tend to focus on the human element and what about the way in which we think as humans affects how the human bias and the AI bias might interplay. So in general, my research sort of falls in this sweet spot, if you will, where the star is. And today I'm going to talk about some ongoing research, and I'm working on a book right now about this topic. So this is a bit of a preview, work in progress, and the whole sort of perspective from an overlap of behavioral economics, artificial intelligence, and CX or customer experience. Okay, so you're all here thinking about consumer or customer insights, right? And so oftentimes the first step when we think about this is to deconstruct the customer journey. And in a digitally mediated environment, we think about the decisions that are made at each touch point, knowing that these decisions are increasingly mediated by technology, right? So you're using algorithms or algorithms are making suggestions to you. You're receiving input from others in social media, for instance. And when we think about these journeys, oftentimes in customer experience, we think about where there might be friction, right? And so there's been a hearty embrace of behavioral economics and thinking about how you can nudge customers through these journeys to reduce friction along the way, right? And so nudging is thinking about ways that you can reduce those barriers or sludge, as Cass Sunstein refers to it. And so nudging being a very sort of important strategy. And this is rooted in the idea that we have this sort of bifurcation of systems cognitively. And Danny Kahneman spoke last week. So this is a nice bridge, I think, from his session the last time. So system one and system two, right? So system one is your automatic thinking, your fast thinking. So when you see a deer pop out in front of a car, you don't have to really think about the physics. Your foot automatically goes to the brake. Versus a system two thinking where, let's say we're all together at a nice event and you're charged with ordering wine for the table. This would be a more deliberative decision, right? And so the goal of nudging is to redesign as choice architects the customer journey to increase the likelihood that we'll get through this journey with minimal obstacles, minimal friction, and minimal sludge. So an example of a nudge that purports to do this, in fact, is defaults, right? And this is actually one of the most powerful nudges. So what you see here in this image is you see organ donations across different countries amongst drivers, registered drivers. And what you see along the red countries, the countries along the red line, is that you have a very high incidence of organ donation, almost 100%. But for the countries along the blue line, you have a relative paucity, right? And what explains this is the reduction in effort or friction that a person would have to engage in that organ donation in the countries along the red line is opt-out. So you're automatically an organ donor unless you choose not to be, as opposed to the countries along the blue line where it's opt-in. Now, when we think about this nudging and we think about this coupled with digital transformation, it really has revolutionized the way we think about customer experience. AI, artificial intelligence, and machine learning in particular has really exploded, where you see $50 billion spent this year. That's expected to more than double by 2024. And so what I think about is the fact that, the cart may be going before the horse in that there's this rapid and massive adoption of artificial intelligence, but not as much commensurate understanding of how this affects human decision making. Does it help? When does it not? And so that's how I spend my days and what my research really focuses on. So understanding that this is everywhere, I'm going to give you some examples in a variety of settings where artificial intelligence or machine learning is interacting with human beings to ostensibly improve decision making. So in hiring practices, a company called HireVue is used by some large financial services firms and others. And the goal is to really whittle down the massive population of applicants into one that's more manageable. So the artificial intelligence will scan a variety of these voluminous resumes and reduce that consideration set based on criteria. And then the human will take it to the last leg and say, okay, now we've got the best of the best and I can make this decision. So this is really a nice example of human and AI interaction, for example. Also in Germany, I know we have someone from Berlin on the call. Doctors for the first time have been able to prescribe digital apps, right? So your physician is not around you at all times. And so this app can serve as a collaborative sort of element to your healthcare. Also, some other sort of collaboration where an artificially intelligent teammate might be able to assess that you're stressed out on the job and therefore step up and become kind of, your sort of relief pitcher, if you will, for the task. And so these are just 3 examples, but this human-AI interaction is truly everywhere, regardless of your industry. It's in just about every industry that you can think of, whether it be behind the scenes or customer-facing. Now, coupled with this idea of customer journeys and nudges, marketers have really embraced this idea of frictionless customer experiences, right? That we want to reduce the amount of friction in an experience. That is to remove any impediments that the customer or the user may have from purchasing the product, for example, right? And so that removal of that friction is meant to improve the customer experience. And indeed, when you look at Google search terms, when you simply put in frictionless customer experience, you see you have almost 6 million hits, or frictionless marketing. You have over 9 million hits. Moreover, there is a positive trend on this, right? So when we look at Google Trends, we see that these search terms have a 10 times increase in interest since 2004 for frictionless CX and frictionless and customer, right? And this really jibes with what we're seeing, where artificial intelligence and machine learning is seen as a way of improving frictionless customer experiences, right? So automaticity reduces the amount of cognitive labor the human might have to engage in. And what this looks like really is a couple examples: frictionless retail. So we see retailers such as Hudson, Aldi, Amazon Go, where they are really embracing frictionless retail experiences. In the case of Amazon Go, your hand is actually your wallet, your identification, and you scan your hand and you don't have to carry a wallet, you don't have to carry your phone, and so on. And in these other retail settings, you collect your items and you just walk out. not having to engage in the friction of having to stop at a cash register or pull out your wallet to make a purchase. Another example of frictionless embrace is in schools. So this is a recent Financial Times article about, in the UK, the use of facial recognition cameras to reduce friction in school cafeteria lines. So when the face is analyzed of the child, there no longer needs to be the friction with regard to paying for lunch or assessing what the child's budget is and how much they have on their card. And as you can see here from the person who is the managing director of the company that's pioneering this facial recognition in schools, the average transaction time was cut to 5 seconds per pupil. So a reduction in friction enabled by artificial intelligence and machine learning. In fact, you might say that there's a little bit of frictionless fever. When you look at discussions of customer experience, we see a frictionless shopping experience. If you're really a customer-first organization, eliminate friction points. The frictionless enterprise. Creating a frictionless end-to-end customer experience, frictionless retail, how to ensure frictionless customer experience, the rise of frictionless, frictionless activation, frictionless commerce, frictionless being 2018's biggest customer experience buzzword, and the fast and the frictionless, which I believe is a movie starring Vin Diesel and The Rock. So when we think about this hearty embrace of frictionless and this so-called frictionless fever, I'd like to sort of raise some concerns. The first concern really is that artificial intelligence and machine learning is often assumed to be neutral, but it's not. And so we really should ask the question, should this be frictionless? Are there circumstances under which friction is a good thing or frictionlessness is a bad thing? So for instance, you see here Google image search terms. And what you can see is that there's bias, gender bias, in the images that are depicted with regard to what kinds of jobs female images are depicted as versus men, right? So women, when you have images with baby, human body, toddler, clothing, romance, swimwear. Whereas for men, you see things like public speaking, management, sports equipment, business person, etc. You can also see this bias in the assessment of lighter versus darker skin, where you see very different images depicting dark skin versus images that depict light skin. So thinking about the use of artificial intelligence and machine learning here, this idea that frictionless is best is concerning when you think about this bias. Another example of this is in the healthcare realm, 64 Black patients losing a chance at a kidney transplant because of an algorithm that had a bias cooked in that viewed Black patients differently from white patients. And if you haven't already, I recommend that you see Coded Bias, the documentary of Joy, who is an MIT doctoral student. Actually, she just received her PhD, looking at facial recognition technologies and grappling with the fact that these facial recognition programs didn't seem to recognize darker skinned actors and Joy in particular. So I'm doing some research with regard to how human decision-making is affected when AI is used and what the implications are for that. And I want to share that sort of work in progress with you today, and then we can come back and loop around and talk about what this means, what the implications are for this frictionless fever and frictionless as a strategy. So the first bit of research I'd like to share with you is some work that I've done with Heather Yang, who's a recent doctoral grad from MIT. And this really looks at who's more likely to trust AI. And the thought here is that not only is algorithmic bias a concern, but the potential interplay of algorithmic bias and human bias is a concern as well. So in this paper, we try to understand what factors affect whether or not someone will trust AI and incorporate algorithmic input into their decision-making versus the same input from a human source. And in particular, as I mentioned before, we're not looking at the features of the algorithm or the artificial intelligence, whether the voice is female or male, although research has looked at that. We're looking at individual level differences. So what is it about people, right, that leads to this outcome? So some previous research that has looked at determinants of trust in AI has shown that people might exhibit what's called algorithmic aversion when the stakes are high and you need to hold someone accountable. So for instance, if you're trying to make a decision as to whether or not you should have an operation, in these experiments, people were far more likely to want to take on the input of a human versus an algorithm, because if things were to go awry, it's really tough to yell at or sue an algorithm, right? But you could go to a physician and say, this didn't work out. In contrast, we see instances where there's algorithmic appreciation, right? So the converse, when people prefer algorithms to humans. So if I were to ask you to guess the weight of this gentleman in the picture here, in experiments where people were given that same task, they made an estimate, and then they were given input from humans or an AI, and they took on the input of the AI in that they adjusted their estimates more from that source versus the human, ostensibly assuming that the algorithm is more accurate in a task setting like this. So as you can see here, this really looks at the features of the task. And what we wanted to look at was the features of the human. So revisiting system 1 and system 2, as I talked about before, it turns out that, we have both systems 1 and 2, everyone, but the dominance of one system versus the other can vary across people. And that one person may be system 1 dominant, so more of an intuitive thinker, and another person may be system 2 dominant, so more of a deliberative, slow thinker, right? And research has shown that this cognitive style, so which one is more dominant, is predictive of a host of things, including whether or not you'll believe fake news, which is work that's been done by Gordon Pennycook and Dave Rand, who's here at MIT and a collaborator of mine, or whether or not you're able to defer rewards, right? So think in the long term versus doing what's kind of enjoyable at the moment, studying today so that you can achieve a goal tomorrow, and other sort of examples of self-control. So if we're thinking about system 1 and system 2, system 1 has people being sort of overconfident in their intuition. And so we could wonder if those people would want to course correct by relying more on algorithms as opposed to humans, or exhibiting algorithmic appreciation. But you could also imagine that system 2 thinkers who tend to be more deliberative may find appeal in algorithmic processing because they're thinking that this is sort of a deliberative cognitive style that matches their own. And so this is an empirical question that we sought to understand. So we ran about 11 studies, maybe more actually, in different domains. And I'm just going to show you one example. We recruited participants from Amazon Mechanical Turk, and we conducted these experiments online. And how this worked was, first we gave them the cognitive reflection test, which essentially is a battery of 5 questions that's meant to measure where on this sort of system 1, system 2 dominant spectrum someone lands. So if you get more of those questions correct, you're a system 2 dominant person, because the questions have answers that appear to be obvious but are in fact inaccurate. So your gut gives you an answer, but that gut is wrong. And so to the extent that you're able to sort of interrupt that automatic intuition, you're more of a system 2 dominant thinker, as opposed to if you get more of these questions wrong and go with what seems to be obvious and intuitive response, you're more of a system 1 thinker. Then we presented them with a variety of scenarios. And this is one from financial advising, but we did this with hiring, college admissions, with healthcare decisions. And so what you see here is people are making choices, and they're given the option of varying the proportion of human versus AI input that will affect their final choice. And so really, if there's no difference, no algorithmic aversion or appreciation, it should make no difference. Everything should be 50-50 down the middle there. So half and half, if you will. But it turns out that that's not the case. It turns out that intuitive thinkers exhibit algorithmic aversion. That is, the more answers you get correct on this cognitive reflection test, in other words, the more of a system 2 dominant thinker you are, the more you exhibit algorithmic appreciation. So system 1 dominant thinkers are algorithmically averse. System 2 dominant thinkers are algorithmically appreciative, right? And so this is sort of a way of thinking about how there's heterogeneity amongst users and how that could be taken into account when we think about what their biases are, right? And how that might interplay with the biases, the potential biases in artificial intelligence. Okay, so there's a question from Jake. Was I able to test whether MTurk participants have seen those CRT questions before? From my experience with MTurk, many people have seen those questions numerous times and know the correct answer. Great question, Jake. Thanks for asking. We did, in fact, test whether or not these folks had seen CRT questions before, and we excluded in our analyses the people who had been exposed to that. So very, very important question, and I'm glad that you brought it up. Thanks, Jake. Okay, so looking at potential alternative explanations, we measured a variety of things, including what Jake has brought up, but we also looked at demographics like your educational attainment, your gender, your race, things of that nature, whether or not you were satisfied with your CRT performance, how confident you are in the domain. So if it's a financial analysis question, whether you feel like you're sort of a finance expert or not, your experience in the past with AI, your personality. And the thing that was significant in the model, those others were not, as a mediator, were the perceptions of accuracy. So this is our ingoing biases that sort of lurk underneath. And essentially what we find is that the cognitive style is predictive of your advisor choice, but that is mediated, right, by people's assumptions about the accuracy. So people with a system 2 dominant style believe the AI to be more accurate, hence that outcome. And so this, I think, is a really interesting case where perhaps we should think about adding friction here. You know, it turns out that people talk about system 2 dominant thinkers as being preferable. You know, they're able to resist a lot of temptation and think long term. They are able to, you know, be clever and less likely to fall for fake news and things of that nature. But in this particular situation, this algorithmic appreciation or this bias toward AI may not be preferable if the AI has bias. Right? So we may think about when we can deploy friction and for whom in this set of research. So moving on to another project that I'm doing with Zivy Epstein and Dave Rand, who are both here at MIT. Ziv is a doctoral student in the Media Lab, and Dave Rand is a professor here in marketing. We started to think about whether or not the involvement of artificial intelligence affects perceived accountability. So if you're making a decision, right, and you confer with or you receive input from an artificially intelligent source, do you believe that you are equally responsible for the outcome? Does that mitigate things? Does that have no effect? What really is the outcome? And so we're looking at this issue. Now, from a literature perspective, independent of AI, we know that when you're making a decision in a group, it lowers your perception of your individual responsibility, right? So there are 60 people on this call. If all 60 of us got together and we decided on some kind of course of action, then ostensibly each individual person's responsibility would be 1/60th of the outcome. And research has shown that there is this sort of diffusion of responsibility, right? So when other people are around, you feel like other people have a responsibility, your accountability is lowered, and it's diffused among the people who are present. So the question is, well, what does this mean given this digital transformation and where human decision-making is increasingly mediated by technology? Some research has suggested that this could create a moral crumple zone. So this is sort of an essay that talks about the fact that with AI, there are many cooks in the kitchen, right? You may be using AI to make a decision or machine learning, but you likely are not the person who coded it. In fact, there are probably many parents of this artificially intelligent or machine learning program. And so your use of it, you may believe, isn't really sort of your responsibility, or you don't necessarily have the accountability when you involve AI in your decision making, thus creating a potential moral crumple zone where I have it sort of, I'm not responsible for this, so I don't really attend to the morality issue as closely as if I were making the decision without the involvement of AI. And a pilot study looked at, for instance, self-driving vehicles and how, reaction time increased as people started to disengage from driving due to these self-driving vehicles. So you can imagine that perhaps this has an effect with regard to the use of AI in decision-making. Now, to think of some examples that may sort of give you a sense of how this could occur, here's an example here with COVID and COVID vaccination access. So think about when the vaccines were first made available and there were all these waiting lists, and algorithms were used to determine sort of who would get priority access to these vaccines. Unfortunately, in this particular case, people who were supposed to be priority did not get first sort of access, and others who were not supposed to be priority did. And so what you can see here is almost an anthropomorphic attitude toward the algorithm, where the doctors say the algorithm clearly didn't work, right? So not them, the algorithm clearly didn't work. Here's another example from the UK. So because of COVID, students were not able to sit their A-levels last year. And so an algorithm was used to take their past academic performance and predict what their scores on their A-levels would have been had they been able to sit the test. And turns out that these algorithms had bias where the students who came from less posh schools were then given lower predicted grades, and therefore really augmenting existing inequality by creating more sort of barriers to entry to top schools. But what you see here is the characterization again of the algorithm, this sort of anthropomorphic, the algorithm caused the grading crisis, right? So you see this sort of decoupling of the human and the algorithm. And we want to know what that means for the relationship between human accountability and AI use. So what happens, and when do people feel like the algorithm made me do it? And is this a threat that could happen? So we ran some experiments to try to understand what would happen if an algorithm gave you input and the ultimate decision turned out to be biased, and whether or not the human, who's the decision maker, would be perceived as being more responsible for that outcome. So we had a series of decision scenarios between Jerry and Bernard. And in these scenarios, Jerry is making judgments about Bernard. These are both fictional people, and these are stock photos. So these aren't real folks. I mean, they're real, but they're not Jerry and Bernard. Okay, so in these various choice scenarios, we have a situation where Jerry has an intuition. And his intuition, unfortunately, is not positive toward Bernard. So for instance, Bernard is an applicant. Jerry has an intuition that Bernard's likely not qualified. Or Bernard is trying to gain admission. Jerry's intuition is that Bernard would not be a good fit. Bernard is saying he has a health issue. He's concerned about some symptoms. Jerry is thinking that perhaps Bernard is mistaken or overreacting. And in a criminal justice setting, Bernard is being charged with something, and Jerry is intuitively thinking that perhaps Bernard is guilty. We then have Jerry take on input from either another human being or an algorithm. And then there is a negative outcome, right? So the negative outcome suggests that there is an error in judgment. And this negative outcome, for instance, in the hiring case, is that Bernard is passed over, but Bernard ends up going elsewhere and winning lots of awards in the industry. Or Bernard is not giving admission, but he goes to another school and turns out to be quite the scholar. And Bernard is correct about his health care, and Bernard is not guilty. So this sort of input from the algorithm interplay with human bias. Now, in this, we had a control condition where, there's sort of no input. And there's an ingoing expectation that the human would be more accurate in this type of case than the AI amongst these respondents. So when asked, who do you believe would be more accurate for different decisions, they believe that the human advisor would be more accurate for these types of decisions than the AI, which we named Prophet. However, turns out that that is not the case, that in fact, the reduced perceived responsibility of the decision maker is commensurate to if a human was making the decision with you. So in other words, Jerry is less responsible to a degree that is the same as if Jerry had conferred with another human being. Basically, this artificial intelligence actor is perceived as a collaborative agent and not just passive. And this is important to think about when we think about this moral crumple zone and how people are assessing the accountability of humans in these human AI choice settings. So from a frictionless perspective, AI is scalable, unlike humans. There's a lot of sort of training for, anti-bias and things of that nature. But, we can't sort of deploy humans to overlook every choice. That's just not feasible financially, operationally, etc. So the good thing about AI, right, is that ostensibly it can debias a lot of these decisions by removing the human element. The problem is, of course, that no AI is neutral or without bias. And when we deploy AI in this frictionless zeal, we may very well be diffusing responsibility at scale, because AI can be used at scale as opposed to an individual whose sphere of influence may be constrained, but an AI certainly is not. So what we are seeing here with this research is that AI is increasingly incorporated into human decisions, but it's perceived as less accurate than humans for complex decisions like the one with Jerry and Bernard. However, when AI is used, it diffuses the responsibility to a level commensurate with another human collaborator. People assume the same level of responsibility reduction or diffusion of responsibility. At the same time, AI is more scalable, right? Can be applied in a far more frictionless fashion than human intelligence for these kinds of joint decisions. So this can give us pause. So what could this mean for friction in the use of artificial intelligence and machine learning? Well, coming back to the issue of friction, I think really one of the suggestions is that friction is not the same thing as a pain point, which often is assumed, and that we should seek good friction to interrupt the potential bias or harm from artificial intelligence. A nice example of this is research done by Penny Cook and co-authors about using an accuracy nudge to reduce misinformation. That is, when people see misinformation in a social media setting and they're ready to retweet or reblog or repost, adding an accuracy nudge that sort of says, a little bit of friction here. Are you sure this is accurate? Think about the importance of accuracy. That bit of friction could reduce the sort of frictionless spread of misinformation in this research. You also see an example here with Instagram trying to add some friction to interrupt bullying on social media. So for example, if someone's about to post something, you see this comment here, you are so ugly and stupid, right? Horrible statements. Having a bit of friction that pops up and says, you know, are you sure you want to post this? We're trying to ask you to rethink your comments so that this is sort of a safer place, a safer setting. So we need to be cautious about this frictionless because friction is not the same thing as a pain point, and actually adding friction could help us reduce harm by interrupting bias, right? So when we think as marketers and we think about serving our customers, we should think about how there's good friction and bad friction, and really err on the side of adding good friction and eliminating bad friction for the sake of customers. Friction can be a feature and not a bug. And so what we should do is think about testing different kinds of friction along the customer journey. And that's something I'm really interested in doing now and looking to dive more deeply into, right? So if you look at a customer journey over time, when is a good time to add some friction? When is it best in the customer's interest to reduce friction, and how this may vary along the customer journey? This is different, right, than the sort of prevailing wisdom right now, which is remove all friction along the journey. That's best for the customer, that's best for us, and that will minimize any obstacles, and we can nudge them along. So artificial intelligence and machine learning is increasingly used in customer experience now, but affirmative choices should also be used to that same level. In other words, reducing friction by reducing agency is not sort of the way we want to go. For responsible AI, we want to give people the opportunity to affirmatively say, yes, I opt into this. Yes, I agree to this, right? And those firms that will do this, that will embrace this responsible AI, may be well positioned over the long term to build trust and competitive advantage, as opposed to the firms who focus solely on frictionless that may bear fruit in the short term, but may cause some problems in the long term, as we see with companies like Facebook right now, and we see other firms being brought to task around these sort of frictionless opt-in or having to opt out of uses of your data, affecting your privacy, and so on. So beware of bad friction. So let me give you an example of bad friction. So here's a product. This is an airbag vest. This is a real product, by the way. And this is something you would use on your motorcycle. And it is the first vest to include artificial intelligence. And that technology will protect you in that it can predict based on the velocity of your movement and so on when you're about to get into a wreck, into a crash. However, when we look at this, we see that the motorcycle airbag vest will stop working if you miss a payment, right? So this is bad friction. This is bad friction in the sense that a customer has adopted the product, and to allow, in order to continue to receive the benefit of it, right, friction is added where you need to keep paying, or else the safety will not be an option for you. This is bad friction. This is using friction in a way that is imbalanced. So if you have very low friction to get people on board and to adopt, but very high friction for them to change their choices, to express agency, or to leave, then you have an imbalance of friction, and likely you're employing some bad friction. But we may think about good friction, right? And so when to use friction, I like to think of U, S, and E. So thinking about this, we should use friction when something frictionless coupled with artificial intelligence and machine learning, can lead to suboptimal outcomes for the humans that we're meant to serve, right? So there have been recent examples, for instance, of police departments using predictive policing, right? Using artificial intelligence in a very sort of Minority Report, Tom Cruise movie kind of way to predict who is going to commit a crime. Now, let me just be clear, artificial intelligence cannot predict who is going to commit a crime. And so when we think about that problem, we can see that there will be suboptimal outcomes for humans. And in fact, there have been people who have been erroneously arrested when they have not committed a crime and when the algorithm or the machine learning was wrong. So we want to think twice about frictionless and add some friction when there's potential harm, and when adding some friction can preserve customer agency. That is, give them the option to opt out, to not be surveilled, for example, or to change their minds. And this is an important part of adding friction. We also should think about adding friction when we should be effortful, right? And not on autopilot with respect to updating our insights about our customers. Just because we programmed, an algorithm or even machine learning, it doesn't mean it will continue to be accurate in perpetuity. Needs change, factors in the marketplace change. And so we need to be vigilant. And there is a real threat with frictionless deployment of AI that the humans within the organization become decoupled, right, from those decisions. That, the sort of algorithm has done all of the cognitive load and we're sort of outsourcing our minds and less sort of engaged or less attentive to what the decisions are. As managers, we can't afford to do that, right? Because as things change in the marketplace, we need to keep pace. So adding friction in the form of experiments is a nice way of maintaining and updating these insights about our customers. At these various touch points, conducting experiments to see whether these nudges work, improve, and whether perhaps friction would serve our customers better is something we should consider. And last but not least, we should use friction when the customer experience is enhanced when we're adding something that will allow them to be more engaged, right? So when, for instance, increasing the deliberation amongst customers serves them well, or when we want to signal to customers that we're taking more time and taking more care. So you can imagine if you are going to a physician who's using artificial intelligence or machine learning, and you say, can you give me a diagnosis? And they just press a button and it says, okay, here's your diagnosis. You may feel some discomfort. It may feel that the doctor really didn't take much time to consider your case. Or in the case of financial analysis, if an algorithm is used that suggests that, the human hasn't really sort of paid close attention to your particular case, this may actually signal something negative to customers, right? So when the customer experience is enhanced, either by the customer being more engaged or by the firm signaling that more time and care is being taken, then adding friction could serve us well. So I'm going to stop here. Thank you all for your attention. This is my Twitter handle, so feel free to engage, and if you have questions after today, feel free to drop me a line. But I know we have some minutes left, so Emily, I will turn it over to you.
Yes, thank you so much, Renee. If anyone has any questions, you can pop them into the Q&A. I will get us started. Which marketing services do you see having the highest potential for AI when used, when used responsibly?
When used responsibly, yeah. So, when I look at the services that use AI to show people the data, I think that, for data visualization, I think AI is actually really influential there. So if you use Spotify, right? At the end of the year, you receive your Spotify Wrapped, which is essentially a highlight reel of all of the music that you've listened to and podcasts that you've listened to during the year. But in addition to that, there's some artificially intelligent kind of analysis of those numbers to show sort of how influential you've been, and to put together kind of an entertaining show at the end of the year, right? So this highlight reel has music, has visualizations, has pop quizzes in it, and so on. So you're seeing artificial intelligence and machine learning adeptly taking in the behavioral data and then using it to report out and give a reflection really to the user of Spotify around how they've spent their time. What I like about that is that it engages the user in the sort of use of AI, and the harms are, sort of absent there. But what I also think is really nice about that is that it enhances the customer experience. If you've ever received your Spotify Wrapped, people feel really sort of pleased and delighted by it and have a tendency to share it on social media, compare other people's Spotify Wrapped, and so on. But what I really like most about it is that it holds up a mirror to the user to say, this is what you've been doing. And, you would think that, like, I know what music I listen to. I don't need anyone to tell me. But it turns out when you see your Spotify Wrap, you realize like, oh, wow, I didn't realize that that was the #1 song I listened to, or I didn't realize that I was in the top 5% listeners of this particular artist. I think that sort of holding up a mirror to the user could be useful in social media to sort of help people understand what they've been sharing, what impact they've been having on other people in their social networks, and whether or not that's kind of, how they want to be. You could imagine that the people who are inadvertently sharing misinformation, for example, don't realize how much of a vector they are for this, right? So using AI and machine learning to kind of give people a sort of mirror into their own behavior, I think could help people course correct, or at least be more engaged in how their behavior is affecting people.
Great. Yes. The Spotify Wrapped is like the highlight of the year, right? We're all excited to find out how many times we listened to that Taylor Swift song. So our next question is from Yu Chang. This is a great question. They're wondering the role that cultural factors may play in trusting or not trusting AI. So there's a perceived higher acceptance of AI in China, but maybe that's due to more willingness to sacrifice privacy for convenience. So that's our next question.
Yeah, thank you, Yu Chang. I think that's a great question. So I think that there are cultural differences, and I think that these differences are wrapped up in regulatory differences as well. So when you look at the United States, and you contrast that with, say, Europe and the GDPR, right? You are training different expectations amongst the customers, and that will sort of lead to different, cultural differences. When you think about China, and you think about sort of, TikTok, the TikTok counterpart in China, and how those data are used to upsell people as they're using the app and so on, there appears to be a higher tolerance, right, for this kind of data gathering and a lack of privacy. But no doubt, that is a reflection of, the parameters within China regarding regulations and regarding privacy norms. So I absolutely do think cultural factors will play a role. And even within a particular country, you could imagine that there would be variance amongst different segments where perhaps people who are more vulnerable may be more suspicious or exhibit algorithmic aversion if there's a history of these data being used in ways that is perceived as nefarious. So thanks for that question, Yu Chang.
Thank you, Renee. Our next question from Sandeep is, how do you trade off scale versus AI error/bias? And the example that he gives, which I think is compelling, is in immigration decisions. Say you have an error rate of 3%, but you could cut the queues, by 10 plus years for immigration. So
yeah, so that's a great question. Thank you, Sandeep. I think I'm very conservative. My own sort of tolerance is very low with respect to the trade-off. When I see things like people being imprisoned for crimes that they didn't commit, when I see, if you've ever read the book Weapons of Math Destruction by Kathy O'Neill, you see the use of algorithms and machine learning in financial services firms that result in people being denied loans. Or you can see this in insurance settings where people are denied insurance coverage. I have a very low tolerance for that kind of harm, because what that does is that not only accentuates inequality, but it sort of makes it calcified. Because once the sort of algorithm is out there, it's difficult or impossible really for any one human being to sort of reverse engineer or undo that damage, right? So in the case of the British schools, for instance, if you're not getting into university, I mean, that really sort of puts you on a trajectory for your life. So for me, I would say how I trade off scale is I would start with anticipating AI bias, and then I would start by making transparent the risk. So you may be familiar with model cards, which were developed at Google by Margaret Mitchell, Timnit Gebru, and other Google AI ethics researchers, or former Google AI ethics researchers. And what they essentially did to try to minimize or reduce the necessity for a trade-off is to give a model card before a model is deployed that is almost like the side of a cereal box. It has kind of all the ingredients. And these ingredients include what are the assumptions, what's the error rate, when this should not be applied, what the likely risks are, when it should be applied, right? I think that adding friction like that is going to make us less likely to have to make these awful trade-offs. And a company that I think that is doing quite well on this is Salesforce. So under their AI ethics team, Kathy Baxter is one of the folks leading that. They really have worked very hard, not only in developing sort of this non-tolerance, right, for harm, but codifying it, making it very clear and transparent and throughout the organization, creating accountability so people are responsible for this. And also, they're talking to their partners and saying, this is what we expect you to do with your data as well. So we want to do business with people who will demonstrate these kinds of AI codes of ethics. So that's my answer there. The tolerance may vary. Mine is quite low. But I think if you do sort of the advanced work and don't assume sort of neutrality, you can minimize this harm and likely anticipate it and make it sort of, transparent.
Thank you, Renee. I think we have time for one more question. And I think this is from Dr. Elaine Tonto. What are the prospects for a strong AI penetration in the global South, specifically in African countries?
Yeah, so thank you for that question, Dr. Tonto. I think that the prospects are very strong. My concern is whether or not the models are representative. So when I say the prospects are very strong, I think that the adoption is likely to be quite high. And as I said at the top of the talk, the pace is more rapid than our understanding of the implications. My concern with respect to the use in the global South and in African countries is that if these models are not trained on data that is representative of the citizens of that country, which is currently the case, this may cause harm and not be accurate in its prediction and potentially cause chaos, right? So I think the prospects of adoption in terms of the adoption rate are quite high, but I also think that the risk is quite high as well. And so to anticipate that, I think that the data will have to be collected from citizens in African countries, for example, and that those biases need to be rooted out. But we can't cut and paste, right? And there is a sort of tendency oftentimes to do that, to say, okay, well, we'll take this model and we'll apply it in a variety of places. That's exactly what we don't want to do, right? Just because a model is suitable in one particular domain does not mean it's a panacea. Unfortunately, in our zeal to reduce friction, that's exactly what a lot of firms are doing. So my concern for African nations is this implicit or built-in bias that is due to the lack of representation in the data sets, as well as the lack of representation in the coders as well. Thanks for that question.
All right, Renee, thank you so much for joining us today. As Renee mentioned earlier, everybody, if you want to get in touch with her, she did provide her contact information, and please feel free to do so if you have anything else, questions that didn't get answered today, or other discussions. And she's put it in our chat also because she's very tech savvy.
And if you're interested in this, please do reach out, because I could talk about this stuff all day.
Thank you, everybody, so much. And thank you, Renee, for joining us today. And I hope everyone has a great week.
Thank you. Bye.